I'm Mike Dvorkin. I have Sergey Lukyanov with me. We're with Hedgehog engineering team. We're going to be talking about VPCs, QoS, and what we're going to do in the future. All sorts of exciting things. Right. So the main abstraction in our product is a VPC. So it's basically the same abstraction as like in a public cloud. It works with the same tools. It's very simple to understand, but like, for those who are like unfamiliar with it, it's basically a unit of isolation in the public cloud. So like VPCs, you can think about it as like a networking sandbox. So we make it so it doesn't really matter how it's implemented under the hood. You're just interacting with a thing that looks eerily familiar from the public cloud days. It can be instrumented in several ways depending on the type of hardware and the type of preference you have on how it needs to work. So it can be done as like VXLAN-based BGP VPNs, and with or without assistance of the switch hardware. It can be done as VLAN VRF. So for the platforms that cannot do VXLAN, or for the platforms that cannot do QoS when you run Rocky V2 in VXLAN. Because you need to like be able to treat QoS like within the inner packet when you're encapsulated. The VPCs can be paired together, so you can like hook them up together. So this way, you can have multiple VPCs for a given tenant, and you can run parts of applications in a different VPCs, or like you basically run dedicated service in every VPC. And then you connect them together. You can translate things, like as far as like address translation is concerned. You might have your separate infrastructure networks where, like, let's say storage is running accordingly. You can hook up your own DHCP. So like if you have like your own IPAM infrastructure and like you don't want to use ours, you can hook it up and like it will work with the tenant stuff, and you don't have to like even think about it. It just works, and you don't have to do much configuration. You just have to like specify where the DHCP service is attaching. Down the road, we'll provide PXE, gPXE booting services for the tenants. And on the gateways, we're working on providing like a lot of network services, like simple load balancing, simple intrusion protection, and various security features. And the way it's going to integrate with like Kubernetes, we're going to be basically a Kubernetes gateway with like full ingress egress function. Questions? All right. So the model, right? Since we're doing abstractions. So the main construct is VPC, and VPC has a number of subnets. For most of the switching stuff, the way you hook up the external compute to the VPCs is through attachment. So basically, we have connection objects that describe the physical connection between a server and the switch. On top of that connection, you can create an attachment. So basically, for all intents and purposes, it's like you're connecting a subnet with a VLAN to the computer. We're going to support other modes of delineation of the tenant traffic. But currently, it's VLANs. And then external stuff you connect via the external constructs. So you can connect to like whatever network. So it basically defines how you get out of the fabric and how you talk to the external networks. And peering, you just peer VPCs together, and you can peer them to the outside. The outside is like a big VPC for us, and that's how we like treat the internet as well. Questions?
No? So the other attachment types, you're talking like VXLAN, you're talking, what are you?
So basically, our VPC is like, think about it as like a VRF. Like you get into the VRF on the VLAN.
Right.
You can get into like VPC as well with the VXLAN. Like, so for example, if you're running some like Calico on the host, we can basically be VTAP for it.
Okay. Got it.
Right. And now, Sergey will show the demo. This is how you do the GitOps and how you create and manage all of our VPC madness with modern tools. And GitHub, Argo CD, and it's using our API directly.
Yeah, so as our API is a basic extension to Kubernetes API, you can use any Kubernetes tools, like Argo CD is one of the most popular GitOps tools for Kubernetes. So, okay, so we have just application set up in Argo CD, which takes a folder from the GitHub repository and configures the objects in our API. We have like two VPCs, VPC1, VPC2 created, and we have server 1 attached to VPC1 and server 4 attached to VPC2. So that's I'm gonna preset up to speed up the demo, and I'll just show how things work. I'll quickly uncomment kind of demo portion and talk about it. I'm just doing commit on the GitHub. So that is an example VPC that we have here. It could have multiple subnets, and each subnet just have the seeder block for it, and you can specify optional gateway. It will be assigned automatically if it's not specified. Then you assign the VLAN, and if you want to use our DHCP that is integrated into a fabric, you can enable it and optionally specify the range for it. If you want to use your own, we provide the DHCP relay servers transparently, so you will just specify the IP address of your DHCP server to be used with this VPC subnet. And we have very granular control on access between the subnets in the VPC and between the VPCs. So each subnet could be isolated, which means that other subnets in this VPC will not be able to access it. And subnets could be restricted, which means that hosts within the subnet cannot talk to each other, kind of guest mode. And we have the permit lists on level of VPC itself, which allows to kind of override. And despite of used isolated subnets, it can allow the traffic between some of the explicitly specified subnets.
Sergey, I have a question. Can I interrupt for just a moment? So early on, you mentioned IPAM, you mentioned DNS and other DDI-like functions. So the IP addressing here, the VLAN information here, is it an engineer picking from an IPAM and typing in this IP addressing gateway and VLAN information, or is there automation that I could use to pull it from a source of truth, like an IPAM platform or Notobot or Netbox or something like that? I'm trying to figure out how you envision the information being populated.
Well, that's just API, so we don't have any integrations with things like Netbox, for example, or other platforms right now, but you can do this integration very easily just by writing, bash script and putting it on a schedule that will just create the object in our API, synchronizing from the external source.
Okay. Are you planning on coming out with like a Terraform provider or
Yes.
something along
Yeah,
those lines?
yeah, we will have the Terraform provider, maybe cross-plane integration, Ansible. Technically, you can do it even today. You can take the Kubernetes Terraform provider. It will work with our API. It's just not great UX, not the best UX you can get with it. But we do plan to have a special Hedgehog Fabric Terraform plugin.
So since these values are not orchestrated from within the platform, what about validation of things like overlaps for IP, reuse of VLAN? What does that look like? Does that just end up as an error in the network, or is there any sort of validation on the back end, like, hey, you've already used this
So
segment or this IP? Yeah.
There are two layers of validation. First, if you're doing some overlap in subnets, for example, or VLANs, it will not allow you to create the object in API. It will be immediate error.
So you are validating that.
We have a very heavy validation. It's every field is double validated, and for more complicated things, The validation will be happening not at the API level, but when we actually generating the state to apply on the switches, it will be validated one more time, and some things will be catched there, and you will see on your, for example, VPC in the status of it, you will see that like this error propagated there.
Okay.
Yeah,
But majority of issues are catched when you're trying to create it through the API.
Another thing to remember, we also have a simulation platform, our virtual lab. You can basically use that for validation. You can like treat it as like kind of like poor man's digital twin.
Digital twin, yeah.
Yeah, and so like you can validate all of the configuration. Obviously, we'll not do like some hardware level limitations, but like at least for like overlapping VLANs,
Yeah.
you can do it as like your like test phase when you're like committing the configuration change.
Yeah.
Is there any validation done before you try to hit the API? Like you have all these YAML files. Is there anything that would examine the content of the YAML file to say, before you try to push this to the network, I'm checking these validations?
So this is what you can do with our virtual lab. So you can first, before you hit our like actual API, you can use the simulation.
Yeah.
And if I see a lot that can do client-side validation as well.
Okay.
So like this way you can pre-validate everything and kind of like do like your own like QA on your configuration, and then as a follow-on step you apply it to a fabric.
Okay.
Yeah. Okay. Well, and other thing to kind of show here is this example of attachment object. We basically saying that the subnet one of VPC3 is attached to one of our servers. And if we'll go to the Argo CD, we can see that there are two more new objects, like the VPC and the VPC attachment that we just uncommented on the GitHub. And I guess now I can show the inspect fabric again. We can see here that configuration on a couple of switches changed, and we got the things applied a couple of minutes ago. That's when we had uncommented objects on the GitHub, and Argo CD pushed them to our API. So now we can go to the pre-created VPCs, and we have these two servers that are just virtual machines that running in the lab, connected to switches, and we already have IP addresses on them that they got from DHCP, from our DHCP, and they're running on the corresponding ports. In that case, it's a VLAN on top of a bond because it's a multi-home connection. And like we have IP address on it, and another one have IP on it as well. So what I want to show is basically connectivity between the VPCs, because they both on a different VPC, VPC1 and VPC2, and connectivity to the external world. So if we'll try ping from the first one, we'll try to ping another server, then we'll not get any pings through. And if we'll try to go outside, it will not work as well, because by default, you don't have any connectivity. So if we get back to the GitHub and uncomment one more portion, then it will enable this connectivity. I'll just push it and comment on it. So basically, those are like two more objects. The VPC peering basically describes a pair of VPCs and which subnets can talk to each other. So in our case, it's just like default subnet of one VPC can talk to a default subnet of the other one. You can specify the like multiple lists of the subnet pairs that can talk to each other. And kind of similar to it, the communication with the external world, we have the abstraction of the external, which could be multiple edge routers that we BGP peer with, and by itself, it will not provide access within any VPC. But if we create the external peering object, we're saying that, yeah, those subnets from the VPC will be exposed to the external world, and we will receive all the routes that are matching these prefixes from the external. And in that case, we basically allow any routes from this external, including the default route. You can specify like multiple filters, and you can specify the prefix length filters as well. So effectively after that, if we look on Argo CD, we can see that the external peering object was created and VPC peering one. So if we get back here, we can see again that some of switches got reconfigured, like this one got reconfigured a minute ago. Basically, like every time you change something through the API and the validation is passing successfully, the new generation of a configuration is prepared, and switches where it needs to be applied receives it, applies it, if everything is working correctly, it will be saved and cached locally. So for the rollback purposes. And now we can basically showcase some of our kind of helpers. For example, like we talked about the we talked about access between the like two IP addresses, and as you can have the VPC peerings, you specify the different like subnets in them. It could be difficult if you know just two IP addresses in a fabric. Could be difficult to say can they talk to each other or not, because there are multiple ways they can reach each other. Especially if one of these IP addresses is like outside of fabric, it depends on many things. And what we provide is like the set of CLIs and the clients that allows you to easily check it, and it's all available in an API. So in that case, we can just specify the source and destination. It could be IP address, it could be server name, name of a subnet. It's all automatically translated to the subnets that are available on this IP address or a server, VPC subnets. You can see here like the source and destination subnets. And it will analyze things through the API, and in that case, it's saying, yeah, the things are now reachable. So if we'll go, actually, let me run one more check. So if we use just the 48, the Google DNS address, it will detect that it's actually not from the fabric; it's external IP address, and it's saying here that it potentially would be available from the default subnet of VPC1, potentially because. In that case, we don't know will we receive the routes from the external world, because we just allow in the like any route.
But at least this is a very powerful ACL debug tool.
Yeah, and under the hood, in real, there are like four switches that get lots of configuration, ACLs, route maps, to allow this routes from external world to filter out that nothing else will get there, etc. So
does this command get more granular than just reachability? Can we say like, can I get there on port 22, TCP 22? Like, can I get down to port protocol?
We will.
Yeah.
That's currently it's only on subnet.
Okay.
We're trying to be very kind to the ACL budget. So currently, like all of the filtering is done on like subnet basis.
Okay.
Once we have the appliance and we're going to have like almost infinite ACL budget, like we'll be able to do that.
So my other question, I saw the VPC peering, which is great when you have a small number of VPCs. When it scales up to a lot, having to peer between all of them individually, right? Like, is there a mechanism coming that'd be like transit gateway or those types of things that would be able to peer a lot of VPCs without necessarily having to do it manually?
You nailed it. So we basically, like, our gateway will be functional equivalent to a transit gateway.
Okay.
Yeah.
So that's coming.
That's coming.
Okay.
Yes. This is not the point of this demo.
Yeah, fair enough.
Yeah. Okay, so if we just go back to this servers, then we can ping between them now as we applied the peering, and the Google DNS, we received some HTML with a redirect. So it means that it can reach outside the world. So kind of one more thing I want to show is I'll start the IPR to run some traffic between them. Those are just virtual machines with not being the CPUs, and there is only 10 gig NICs in them. So it will not be like very fast, but yeah. So if we get back to the slide, so what we do like for observability is basically we're running the Grafana alloy on every switch, which collects a bunch of the local metrics, both from our agent and through the agent from the ASIC on a switch. Plus, it collects a lot of data from the host itself, from a Linux side of it. And it allows to configure sets of targets to push these metrics and logs for the Prometheus, like Mimir compatible API and Loki compatible API. We will add more things in future. For example, you can do like open telemetry as well. And we collect things like all of our agent logs, and we collect the syslog from the switches as well. So you're getting most of the information that you need for debug, including the counters on the ports, including some of critical resource information on the switch, like limited ACLs, route tables. All of that becomes available in your monitoring tool of a choice. And you still can use any network management tools with a Sonic. And as we were saying before, we're not occupying the management port. So if you want to run something that will use a management port like SNMP, or you want to use like IP MIO switches, it's still available. Like management port is not occupied. So if we get back to the demo and we can run the inspect on a switch. Oops. Actually, let me show the Grafana dashboards first. So we're not shipping Grafana and Prometheus with the product right now. We do plan to add it as an option. If you want to run it on our control plane, then you will be able to just use one checkbox and it will run the Grafana Prometheus Loki stack. But we ship, like in our documentation, we ship a set of example dashboards that you can use. This one, for example, is just pretty standard on Node exporter. It's just a Linux side of a box. It's like very lightly modified just to have the needed selectors, but generally that's just like upstream one. And we do add things like this platform view, which shows all the sensors and fan speeds and PSU information, all like the switch critical resources that I was talking about, like usage of the ACL groups and etc. There are quite a lot of things on the switch that you want to be like careful about. The other thing that you can see that basically counters on the interfaces, and as we started IPRF, you can see now that we started getting some traffic. There's like about like 9 even and a bit gigabits of traffic on the ports, yeah, that is just it is the kind of same kind of information is available through the API as we have a snapshot of it. So that was let's see another switch. So as it's multi-homed, we don't know exactly on which switch the traffic will go through. So you can see now that I just checked another one, and you can see the traffic going in and out on the ports. Basically, this one is a port that is connected to the server. And if we look here, we can see that's carrying the connection that is server 1 MCLAG. And this one is a spine connection. You can see here it's a fabric connection to the spine. So yeah, I think that's all we wanted to demonstrate.
Does the system support streaming telemetry?
It will next year.
Yeah. Okay.
Yes. That's why we put on the slide. Because we guess like someone's going to ask this question.
Oh, yeah.
All right. So the QoS. So we provide the QoS model that fits into this VPC thing. So we do tenant traffic prioritization, flow level control. So you can specify what flows you want to classify in whichever way. We support lossless through like configuring and manipulating Rocky V2 and all the things related to that. So you can have VPC and the congestion notifications. So at the fabric ingress, as you're entering the fabric, we classify tenant flows and basically assign the priority to them. And then the rest of the fabric is basically honoring the priority of the traffic. So the way it works, so you get in, you mark with DHCP, we mark both in and our packet, and then in the rest of the fabric, you just basically honor it and you assign like resources, human resources accordingly. Yes?
Hi, this is Micheline Murphy, Worldwide Technology. PCN and, PFC and ECN aren't really scheduling fabrics. And the switches aren't really talking to each other to actually schedule.
They're not. We will talk about, like this is a roadmap item. Like
Okay.
One of the things we're working on is the scheduled fabric.
Yeah, because the scheduled fabric and PFC aren't the same.
They're not the same thing.
Okay, I just wanted
We're
to,
not advocating. At this point, we're supporting like basically Rocky V2.
okay,
We're working on supporting the scheduled fabric.
okay. Are you, just to be clear, are you supporting the PFC and ECN now?
Yes, we do.
Okay.
Right. So these are the priorities. So we have 3 tenant priorities for lossful traffic and 2 lossless queues. And the rest of it is like for the protocols and management traffic. So like you can actually squash it. So like our control plane doesn't crowd out the tenant traffic. Roadmap. we have the physical network today. So it's basically the open network fabric. Runs on top of the Broadcom-based white box and gray box switches. Later this year, service gateways are coming out, then DPUs, and then the flow scheduler. So, and for the flow scheduler, once it's ready, we're going to do a separate demonstration. It's going to be really, really, really cool. It's not going to work on top of Sonic. It's going to have access to the switch resources directly without the SI abstraction, because SI abstraction is very restrictive. And it's kind of hard to do it with normal Sonic. So we'll just basically run Linux with our control. If you want to learn more, go to our website, hit the contact form, talk to us. You want to download it and try it out? Download. You want to browse around the code and see like if it's for real and like if the code is reasonable? It's all on GitHub. Like everything we do is completely open source. So we're not trying to lock you in. We're just trying to build something really, really cool and useful. Device support, go to the SLA page. Follow us on Twitter, gethedgehog.com. Want to follow me? I'm working.